In this video, I'm showing you my current card prefab and the two scripts that I've built so far, which is going to be CardBehavior and TJCardPhysics. So a prefab is an object that's saved in Unity that's reusable. All of the objects plus the components and the settings. So this is what I have so far for the card prefab. You can open up to just see the card prefab by clicking the top right open. And then here we'd be able to change anything. Now this card prefab is going to be relatively simple, so there's not much that I'm going to need to do on this screen, at least for right now. And again, a big win for prefabs is its consistency. I can spawn 50 cards and they all start with the same collider, the same scripts, the same box render, the visuals, the tags, the layers, etc. And then if I update this prefab, all of the cards that I spawn in the game scene will inherit those changes. Now, you may be looking and seeing that there's no rigid body. A rigid body allows this game object to interact with the card physics or the physics engine that Unity provides. A lot of card games don't need full Unity physics. If I add a rigid body, Unity's physics engine will try solving for collisions every single frame. And this can create unpredictable behavior, such as card jittering, card sliding, bouncing, weird stacking, especially when you start moving the card around. So for right now, I decided to not do the rigid body. And I was also looking at the 3 completed card games, and none of those people decided to use the rigid body as well. If I ever wanted to add physics later, I can, but I would like to add it for different objects. Maybe if I found a way of including dice in the game or something like that, the rigid body would be included here. Now I was going through the 3 completed games, and I did notice that their scripts were very modular, where they had a lot of very small scripts. So, for example, I decided to replicate that. So I have the card physics script, which is going to be the visual position or the height of the card while it's dragging. It's also going to be resolving overlapping as well. And then I have my card behavior script, which is going to be input and dragging logic, and then it's also possibly going to be stacking behavior as well. Now I'm going to go into the different scripts. In this video, I'm going to explain my card behavior script line by line. This script is responsible for allowing the card to be clicked and dragged using the mouse. It works by converting the mouse 2D screen position into a 3D world position and then moving the card to that position. In future, I'm also going to have stacking behavior on here as well as any other card controlling. So the using Unity engine, this is a line that tells C# that we're going to be using this namespace, which is going to be a library of code. This gives me access to the built-in Unity systems like Vector3, Camera, Ray, Plane, and Mono Behavior. The third line creates a script called Mono Behavior. The colon means that it is inheriting, and then from the Unity's Mono Behavior. This allows the game object to be controlled through the Unity engine, and it gives us access to special functions like start, update, on mouse down, on mouse drag, things like that. The 6th line, private cam, dash cam, all of these are going to be fields that must be declared before they are used later in the script. The private camera dash cam creates a variable that will store a reference to the camera. I need access to the camera so I can convert the mouse position on the screen into a position in the game world. I have a comment so that way later in the future I'll know that these fields were used for dragging the card. Private plane and then drag plane. Private defines the scope, so it's only accessed in this script. Plane is going to be a constructor. It's an invisible 3-dimensional flat plane. I need this, or I use this to calculate where my mouse ray intersects a world, and then I'm setting it equal to drag plane. Because this is a private variable, I'm using a underscore. We also have a private vector 3, which is going to be drag offset. This stores the difference between where the card is and where the mouse hits the plane. This prevents the card from snapping its center to the mouse when I click on it. I have a boolean, which is going to be true or false. It's public because it's going to be interacting with another script, so it must be accessible to that script. And it tracks whether the card is being dragged. Now, void start, this happens once the object is created, and then this is going to be storing a reference to the tagged main camera. And it's going to store that in underscore cam. This is going to allow the script to use camera later. And then private void on mouse down. This is a function that is accessible in the Unity engine. And it checks to see when I click on the game object, whether it's colliding with the card's collider. Once that happens, it's going to set is dragging equal to true, meaning that the card is now being dragged. And then the drag plane, this creates a mathematical plane. Vector 3 up means that the plane faces upward like the ground. And then vector 3.0, this is passing through a position of 0, 0, 0, which is the initial location of the card. So this is creating an invisible flat plane with height y, which equals to 0, and the original location. The vector 3 mouse world get mouse point on plane. This is a function that calculates where the mouse ray intersects the plane. The result is a world position. And then the drag offset, this calculates the offset between the card and the mouse. This prevents the card from snapping to its center to the mouse position. Instead, it maintains the exact point where I grabbed the card. And then here, private void on mouse drag. This is a function where every frame it's called, whether the mouse button is held down on the card. The if it is not being dragged or we don't know where the main camera is, it's going to return. So if the card is not dragging or the camera does not exist, if either is true, the script stops. The return means that it's being kicked out of the function. The vector 3 mouse world get mouse world position point on plane. This is again, it gets the current position, world position on the mouse on the drag plane. The vector 3 target mouse world plus drag offset. This calculates where the card should move by adding the offset to the mouse position. And then target y transform that position. The CardPhysics script is going to control the height of the card, so I do not want this to change. Instead, this is going to take into account the X and Z position, so I want the card to move to the new position where the mouse is. And then on mouse up, this is going to be setting dragging equal to false, so it stops dragging. The void update script is currently empty, but then the private vector get mouse world on plane. So this is a function that's going to convert the mouse position into a world position on the plane. Array, similar to a vector, is unlike a vector though, is going to have a start position and then it is traveling a certain distance. This is creating array from the camera by passing through the mouse position, and it's going to be shooting out where the mouse is. And then if it checks to see if it hits a drag plane, so if it hits the card, and then Unity stores the distance in the variable enter, and then it's going to return. This gets the exact world position where the ray hits the plane and returns it, and then it's going to return if something fails, the card stays in the current position. So overall, the script works by creating an invisible mathematical plane, shooting a ray from the camera through the mouse, finding where that ray intersects the plane, and then moves the card to that position while maintaining the correct offset. This gives a smooth, predictable drag, without using the Unity's physics engine. In this part of the video, I'm going to explain my card physics script line by line. I have my nickname because there is several other card physics scripts. I want to make sure that my project is accessing this one, so I have it named like that. The purpose of this script is to control the vertical height of the card depending on whether the card is being dragged or not. When the card is being dragged, it moves upwards, and when it's not being dragged, it returns to its rest height. Eventually, this script will also resolve overlapping, pushing the cards away from each other. So using Unity Engine, again, this is a line of code that gives access to all of the functions, methods that the Unity Engine provides. We can go here, public class TJCardPhysics, monoBehavior. So I'm creating a script named TJCardPhysics, and it is inheriting from the monoBehavior class. Private CardBehavior -behavior. This is a reference. Instead of a reference to a camera, this is going to be a reference to another script on the game object. So this is going to create a variable that stores a reference to the card behavior script on the same game object. This allows the script to check whether the card is currently being dragged, right, from the public is dragging field from the last script. Then I'm creating two private floats, a Y offset for rest height, which is going to be slightly above the card mat, and then the Y offset drag height, which is going to be a little bit higher at 0.5. This allows me to change these float values, which are going to be decimal point values, inside of the inspector. Now at the void start, this happens once the object is created, and then here I have the -behavior get component card behavior. So similarly to finding out the tagged main camera, this is getting the behavior script that's attached to that game object, and this allows the script to access the is dragging variable. On void update, this is going to happen once every frame. This means it's constantly checking whether the card is being dragged. And then here we have the vector3 position.transform. This creates a copy of the card's current position. Transform.position is the current world position of the game object. This stores it in a variable called position, so it can be modified. And then this is just a simple if-else function. So if inside of the behavior, which is the card behavior function that I created a reference to in the start, if it is dragging, so if this is true, then the position.y is going to be set to the drag height, which would be 0.5 float. Otherwise, it's going to be set to the rest height. And then, once the .y position is being set, then this applies the updated position back to the card. So this moves the card to the new height. So what this script is doing very simply is simple and controlled. Every frame, it checks whether the card is being dragged. If it is, the card is lifted upward. If it's not, the card is returned to its resting position. This creates a visual effect of the card being picked up and placed down. The card behavior script controls the X and Z movement of the card, while this script controls the Y movement of the card, the up and down. By separating these responsibilities, the system stays modular and easier to expand. If this approach avoids using the Unity rigid physics engine, which can introduce unpredictable behavior, instead I directly control the card's position, which gives full control and predictable results. Right, now we are back in the game view. This is what the game looks like currently. So what's happening here is the card behavior script is detecting my mouse input and moving the card in the X and Z directions by projecting the mouse onto an invisible plane in the world. At the same time, the TJCardPhysics script is constantly checking whether the card is being dragged. When it detects dragging, it lifts the card upward into a higher Y position, and when I release the mouse, it returns the card to the resting height. By separating these responsibilities, one script handles input and movement, while the other handles the visual effects of the card being lifted and placed down. The next thing I'm considering adding is tweening, also called in-betweening. Right now, the card instantly snaps from drag height back to rest height. With tweening, I can make this transition smooth. Over time, this will simulate gravity and give the illusion that the card is falling naturally rather than snapping into place. Alternatively, I may begin working on the stacking mechanic. The first step will be simple. When I pick up the card and drag it over another, I want it to be able to detect that card and then create a debug log in the console that says stacked. This will confirm that the detection system is working. Later, I will build on this to actually move the card into a stacked position and create a list of cards, which I can then introduce into the chemistry game. I'm trying to take this one step at a time. My goal is to fully understand each system before moving on to the next one, rather than rushing ahead and creating something I don't fully understand. Thank you again for watching. I really appreciate your support, and I'm excited to continue learning and improving on this project. Have an amazing day.